There is no universally mandated standard wire color specifically designated for the high leg, sometimes referred to as the stinger leg, wild leg, or bastard leg, of a delta transformer configuration. While in practice, certain colors may be more commonly used in some regions or by some electrical contractors, relying solely on wire color to identify the high leg is extremely dangerous and can lead to severe electrical hazards. The high leg in a delta transformer system arises from the center tapping of one of the transformer windings to create a neutral point. This configuration results in one phase having a higher voltage to ground than the other two phases. This higher voltage phase is the high leg. Because there is no specific color code required by the National Electrical Code, NEC, or other widely adopted electrical standards, the actual color of the wire used for the high leg can vary. It is important to emphasize that any color could be used depending on the installer and local practices. Some electricians might use orange, red, or yellow, but this is not a guaranteed practice. The critical point to understand is that relying on color coding alone is unreliable and potentially life-threatening. To accurately identify the high leg, a qualified electrician must perform voltage measurements using appropriate testing equipment. This involves measuring the voltage from each phase conductor to the neutral conductor, if one is present, and to ground. The phase conductor with the highest voltage to ground is the high leg. The typical voltage readings in a 240 volts delta system with a high leg are approximately 240 volts between phases, 120 volts from two of the phases to neutral, and approximately 208 volts from the high leg to neutral. However, these voltages can vary slightly depending on the specific transformer and the load on the system. It is crucial to consult the transformer's nameplate and wiring diagram for accurate voltage information. Furthermore, the specific voltage to ground of the high leg depends on the system's design and the transformer's characteristics. Therefore, voltage testing is the only reliable method for identification. Always exercise extreme caution when working with electrical systems. Electricity is dangerous, and improper procedures can result in severe injury or death. If you are not a qualified electrician, do not attempt to work on electrical equipment. Instead, contact a licensed electrician to perform the necessary work. It is also worth noting that the NEC, while not specifying a color code for the high leg, does have requirements for marking the high leg at specific locations. For instance, NEC section 110.15 addresses high leg marking. According to this section, where the neutral conductor is grounded, the phase having the higher voltage to ground must be durably and permanently marked by an outer finish that is orange in color or by other effective means. This marking must be visible at each point where a connection is made if the grounded conductor is also present. This requirement aims to provide a visual indication of the high leg's presence, but it does not eliminate the need for voltage testing to positively identify the high leg before working on the system. The purpose of the orange marking is to alert electricians and other qualified personnel to the presence of the high leg, so they can take appropriate precautions. It is important to remember that this marking requirement applies only where a neutral conductor is present and grounded. In some delta systems, a neutral conductor may not be present, in which case this marking requirement would not apply. It is also important to check local electrical codes, as they may have additional requirements for marking the high leg. Some jurisdictions may have stricter rules than the NEC, so it is essential to comply with all applicable regulations. In summary, while there is no standard wire color for the high leg of a delta transformer, the NEC requires that the high leg be marked with an orange color at certain locations where a neutral conductor is present and grounded. However, relying solely on color coding is dangerous and unreliable. Always use voltage testing to positively identify the high leg before working on any electrical system. And if you are not a qualified electrician, do not attempt to work on electrical equipment. The risks are simply too great. Always consult a licensed electrician for any electrical work. Delta transformers are used in various applications to provide three-phase power. The delta configuration offers advantages in certain situations, such as when a neutral conductor is not required or when it is desirable to minimize harmonic currents. However, the presence of the high leg can be a disadvantage in some cases, as it can complicate the wiring of single-phase loads. Therefore, it is important to understand the characteristics of delta transformers and the implications of the high leg before using them in any application. When working with delta transformers, it is also important to be aware of the potential for circulating current. Circulating currents can occur when the transformer windings are not perfectly balanced, or when there are differences in the impedances of the different phases. These currents can cause overheating and damage to the transformer. To minimize circulating currents, it is important to use high-quality transformers and to ensure that the windings are properly balanced. It is also important to use appropriate grounding techniques to prevent ground faults. Ground faults can occur where a phase conductor comes into contact with ground. These faults can cause dangerous voltages to appear on the equipment grounding system. To prevent ground faults, it is important to use properly sized grounding conductors and to ensure that all equipment is properly grounded. In addition to the above considerations, it is also important to be aware of the potential for voltage imbalances in delta systems. Voltage imbalances can occur when the loads on the different phases are not equal. These imbalances can cause motors and other equipment to overheat and fail. To minimize voltage imbalances, it is important to balance the loads on the different phases as much as possible. It is also important to use voltage regulators to maintain a stable voltage supply. Furthermore, power quality is also crucial in delta transformer systems. Power quality refers to the characteristics of the electrical power supply, including voltage, frequency, and waveform. Poor power quality can cause a variety of problems, including equipment malfunction, reduced efficiency, and increased energy costs. To improve power quality, it is important to use power conditioning equipment such as surge suppressors, harmonic filters, and voltage regulators. These devices can help to mitigate the effects of power quality problems and ensure that equipment operates reliably and efficiently. When selecting a delta transformer, it is important to consider the specific requirements of the application. Factors to consider include the voltage, power, and frequency requirements, as well as the environmental conditions. It is also important to choose a transformer that is appropriately sized for the load. An undersized transformer can overheat and fail, while an oversized transformer can be inefficient and costly. In addition to the above considerations, it is also important to consider the transformer's efficiency. Transformer efficiency is the ratio of the output power to the input power. A more efficient transformer will consume less energy and generate less heat. Therefore, it is important to choose a transformer that is as efficient as possible. Finally, it is important to consider the transformer's reliability. A reliable transformer will operate without failure for many years. Therefore, it is important to choose a transformer from a reputable manufacturer with a proven track record of reliability. In conclusion, while there is no standard wire color for the high leg of a delta transformer, it is essential to understand the characteristics of delta transformers and the implications of the high leg before working with them. Always use voltage testing to positively identify the high leg before working on any electrical system. And if you are not a qualified electrician, do not attempt to work on electrical equipment. Always consult a licensed electrician for any electrical work. By following these guidelines, you can ensure that you are working safely and effectively with delta transformers. Understanding the nuances of electrical systems is paramount to ensuring safety and preventing potentially hazardous situations. The absence of a standardized color code for the high leg in delta transformers underscores the critical need for qualified professionals to rely on voltage testing and adhere to established safety protocols rather than relying on assumptions based on wire colors. Moreover, the NEC requirement for orange marking on the high leg where a neutral is present further reinforces the importance of visual cues in conjunction with electrical testing. However, it is imperative not to equate the orange marker as a universal indicator, as it might not be present in all delta systems. The comprehensive understanding of the transformer's characteristics, system configuration, and potential hazards are crucial for safe operation and maintenance. Factors like balancing the load, considering the transformer's efficiency and having insight of power quality aspects contribute to robust electrical infrastructure. A licensed electrician will consider all of these, as they are knowledgeable about electrical codes, grounding techniques, and voltage regulation, which will help prevent electrical hazards and ensure that equipment operates reliably. The consequences of improperly handling electrical systems can be severe, ranging from equipment damage to life-threatening injuries. Therefore, it is always best to err on the side of caution and seek the expertise of a qualified professional. The qualified professional will have the right tools, knowledge, and experience to handle the intricacies of delta transformer systems and mitigate any potential risks. In addition to adhering to safety guidelines, it is equally important to prioritize ongoing education and training in the field of electrical systems. Continuous learning about the latest technologies, codes, and best practices helps professionals stay abreast of advancements and maintain a high level of competency. This commitment to lifelong learning ensures that electrical work is carried out with utmost care and precision, minimizing the likelihood of errors and promoting a safe working environment. Furthermore, a proactive approach to safety involves regular inspections and maintenance of electrical equipment. Identifying and addressing potential problems before they escalate can prevent costly repairs, downtime, and, most importantly, accidents. Implementing a comprehensive maintenance program, including routine checks, cleaning, and component replacements, helps prolong the lifespan of equipment and maintain its optimal performance. In conclusion, the absence of a standardized wire color for the high leg and delta transformers underscores the importance of relying on professional expertise, adhering to safety protocols, and prioritizing ongoing education and training. By combining technical knowledge with the commitment to safety, we can ensure that electrical systems are operated and maintained in a manner that protects both people and property.